Hiya, this is Year 2 Pure, Chapter 9, Lesson 6, and today we're going to be differentiating trigs. Specifically, we're going to be differentiating tan, sec, cosec, and sec. Okay, to be able to do this lesson effectively, you really need to be able to use the chain rule, you need to be able to use the product rule, you need to be able to use the quotient rule, and you need to be able to differentiate basic trigs, so that's sine and cos. If you can do those things, you should be absolutely fine accessing this. It looks a bit scary at certain points, but it's not overly difficult. Okay, let's get cracking. So in the first question that we're going to see, this is just a way for us to prove the derivative of tan of x, and so we're going to have a little look at how that's done. If we've got y equals tan of x, we're going to try to give dy by dx. Now we don't know how to differentiate tan, we have no idea, but we do know that tan is identical to sine of x over cos of x, which is great, okay? And now that we've spent a bit of time on this chapter, we know how to differentiate each of these, but we also know how to differentiate a function over a function. And we're going to be using the quotient rule to do that. So we're going to let this equal u, and we're going to let this equal v. And so we've got u equals sine of x, du by dx is going to equal, if you've got sine, cos, negative cos, and we're differentiating sine, then you're going to get cos of x. Okay, and for v we have cos of x, and so when you differentiate dv, by dx, you're going to get negative sine of x, and v squared is going to be cos squared x. And so the quotient rule, dy by dx, will be equal to v du minus u dv all over v squared. And so we'll have v du is going to be cos of x multiplied by cos of x, which is cos squared x, minus u dv, which is going to be sine of x multiplied by negative sine of x. Now it's going to be negative sine squared x, but there's already a negative in there from the quotient rule. And so we're actually going to make a positive there, over v squared, which is cos squared of x. Okay. Now, the numerator, you've got cos squared x plus sine squared x, which is 1 over cos squared x. And so tan of x differentiates to 1 over cos squared x, and more commonly that's just written as sec squared x. Now that's just differentiating tan of x. You can use a chain rule if you want to differentiate tan of k of x, but that is this. Tan of k of x differentiates to k sec squared kx, which is pretty much what you'd expect. Okay, it's not overly complicated. You might want to try proving that yourself using the identity known from the previous slide. Make sure that this thing here is written somewhere safe. You know where to find it so that you can use it. You don't have to keep flicking back through your pages in your book. All right, so let's try out this question. We have y equals 3x squared tan of 4x. Now in this case we have, it's either a product, a quotient, or a chain rule. Take a look at it and have a think. Which one do you think it is? It's a product rule. We've got a function multiplied by a function. Okay, we've got 3x squared multiplied by tan of 4x. I'm going to let this be u, and I'm going to let this be v. Okay, so u will equal 3x squared, and so du by dx will equal 6x, and v will equal tan of 4x, which looks really scary, but it's really easy to differentiate, especially when it's written here. You'll get 4 sec squared 4x. All right, to complete your product rule, dy by dx will equal 3x squared multiplied by 4 sec squared 4x, which will be 12x squared sec squared 4x, added to 6x multiplied by tan of 4x. And you know, you might be asked to factor out the 6x or something like that, but in this case we'll just leave it as it is. That should be fine. Okay, next we've got tan squared of 3x. Have a think, is this product, chain, or quotient rule? In this case, this is the chain rule. We've got y is equal to tan of 3x squared. So y is equal to u squared when u is equal to tan of 3x. You should be pretty quick now with the chain rule. We can diff the outside and diff the inside, multiply those things together and you're done. Okay, you should be pretty quick. If you want to take a little bit more time over it, you can. We've got diff the outside is going to be 2 tan of 3x has to be multiplied by diff the inside, which is going to be 3 sec squared 3x. And you just tidy that up and you're done. 6 tan of 3x sec squared of 3x. All done. Okay, not too bad. All right, moving on. We've got if y equals sec of x, show that dy by dx equals sec of x tan of x. All right, well, this looks pretty scary because you're going from sec of x to tan of x, sec of x tan of x. But remember, you're not trying to make these two things equal to each other. You're trying to differentiate this, differentiate it and see what happens. Okay, so if we've got y equals sec of x, well, sec of x is 1 over cos of x. So we know that y equals 1 over cos of x. So u equals 1 and v equals cos x. Differentiate each of those. Okay, let's take a look, see what you got. Well, when you differentiate a constant, you get to 0. Okay, we should know that. And when you differentiate cos of x, you'll get negative sine of x. And v squared is going to equal cos squared x. So dy by dx is going to equal v du, which is going to be cos of x multiplied by 0, which is 0, minus u dv, which is one lot of negative sine of x, so you get negative, so you get plus sine of x there, all over cos squared x. Okay, and all we need to do now is we've got sine of x over cos squared x. That is the derivative, that's the derivative. We just need to make sure that we can make it look a bit like that. And the way to do that is to break it up into sine of x over cos of x multiplied by 1 over cos of x, which is equal to tan x sec x. All done. Okay, and similarly to the way that I mentioned with tan, you could make this into a kx, and you could find out what the form is for the derivative of that. You can use chain rule for it. But those cosec, sec, and cot have their own rules. I suggest pausing the video, write them down somewhere safe. Okay. So if y equals sec of 4x over 2x squared, find dy by dx. Now we're getting into the big stuff, okay? This is a bit scary looking. Take a look at it. Have we got product, chain, or quotient? So obviously we've got the quotient, haven't we? Okay, where u is equal to sec of 4x and v is equal to 2x squared. So du by dx, sec of 4x will be 4 sec of 4x tan of 4x. 4 sec 4x tan 4x. And dv by du will equal 4x. V squared will be 2x squared squared. Be really cautious here. Have a think, what could people do wrong? Well, what they do wrong is they just square the x squared and get x to the power of 4, but you need to multiply the 2 by itself as well to get 4x to the 4. Watch out for that. It's a real basic move, but when you're spending so much time focusing on really advanced stuff like all of these, that basic move can really often go wrong. Okay, remember it's the entirety of v, all of it being squared. Just be really cautious with that. So, to get our derivative, we're going to be using dy by dx, and it's going to be v du, 2x squared multiplied by 4 sec of 4x tan of 4x, which is going to be 8x squared sec 4x tan 4x minus u dv, which is going to be 4x sec 4x all over v squared, which is 4x to the power of 4. And we can cancel off quite a bit. We can divide through by 4x for every single term, and so when I do that, I'm going to end up with 2x sec of 4x tan of 4x minus sec of 4x, and dividing through by 4x on the denominator will be x cubed. And you can even, if you want to, you can factor out the sec of 4x, so you could get sec of 4x multiplied by 2x tan of 4x minus 1 all over x cubed. Okay, so you could be asked for different forms just based on whether you factored or not. All right, but that's what dy by dx can look like. All right, moving on. If y equals cot cubed of x, so take a look at it. You might want to pause the video and maybe try it out in advance. So think about it. Have we got the quotient rule, the product rule, or the chain rule? Well, in this case, this is the chain rule. You've got y is equal to u cubed when u is equal to cot of x. This looks so scary, but it's really simple to do. Dy by du will be 3u squared, and so therefore dy by dx. Therefore, you've got 3 of u squared there, and du by dx will equal, well, cot of x, you get negative cosec of x. And all we've got to do is multiply those things together. So you'll get dy by dx is going to equal 3 cot squared x multiplied by negative cosec x. It's going to be negative cosec of x. All right, nothing too scary. Again, pretty simple really, not too bad. Looks very scary, but it's got really simple steps. So all you need to do is be able to follow those steps. If you're struggling with the chain rule, go back to it. If you're struggling, with product and quotient when they come up, go back to it, practice it. All right, I think this is the last question for this lesson. So we've got, given that x equals sine of y, where y is between negative pi over 2 and pi over 2. This is really scary, quite intense, this thing. Show that dy by dx equals 1 over root of 1 minus x squared. This looks pretty brutal. There are problems with it. First off, you've got x equals sine of something. And of course, you could get y equals sine to the negative 1 of x, but we have no idea how to differentiate that. Okay, we have no idea what to do with the inverse of sine. Okay. We've also got this domain thing here. What I would suggest doing is plotting this into GeoGebra. Have a look at why they've restricted this domain. It's quite interesting about why it is that they've restricted that domain. And we're going to be showing something that doesn't even have trig in it. All right, so first thing is, when you're dealing with x equals sine y, we're going to differentiate x with respect to y. Look carefully, this is dx by dy. Normally we're used to seeing dy by dx, but we're going to differentiate x with respect to y. Now when you differentiate sine, you get cos. Okay, and so therefore dy by dx will equal 1 over cos of y. We know this is true, this is the way it is. But we need to somehow make that look like this. So essentially the majority of this question is show that 1 over cos y is equal to 1 over the root of 1 subtract x squared when x equals sine y. And we've got to work on the left hand side, we have to. We can't just use this bit here, even though we're sort of tempted to. Now take a good look at it though. There are things that you can see that are really nice. If x is sine y, then 1 minus x squared would be 1 minus sine squared y. 1 minus sine squared y is cos squared y. And when you root that, you get cos y. So we sort of know what we're going to be dealing with here. Okay, we sort of know what we're going to be dealing with. So what we're going to do is we're going to look at the trig identity, which is this one, which is sine of sine squared y plus cos squared y equals 1. We know that. Okay, that's definitely the case. We're going to deal with cos squared y is equal to 1 minus sine squared y. And we're going to say that cos of y is equal to the square root of 1 minus sine squared y. Okay, so we're going to plug this into here. This is just using an identity. I'm going to plug that into here. So we'll get 1 over cos y is equal to 1 over root of 1 minus sine squared y. But we also know that sine squared y is equal to x squared. So 1 over the square root of 1 minus sine squared y must equal 1 over the root of 1 minus x squared, which is what we wanted to show. Okay, it really does pay to have a look though, when you're going from the left hand side to the right hand side, have a good look at the right hand side. What can you spot? What do you know? Because all I had to do was a pretty simple rearrangement and then just to plug it. But it does look quite scary to go from that to that without any clues. So you need to develop your own clues by having a look at that right hand side really, really, really in depth. Alright, hopefully this video helped. Thanks very much for watching. Good luck.